In this video, we're going to take a look at one of the most powerful and time-saving algebra tricks ever. I've tutored hundreds and hundreds of students, and I have never seen any of them use this trick. I don't think anyone really knows about this. So stay tuned so you can learn one of the best algebra tricks ever. Hey everyone, it's Brian. If you're looking for all the lessons and tricks to make math easy, start now by subscribing. One of the most hated things to do in math, in algebra, in pre-calc, and even in higher level math is solving systems of equations. Everybody hates doing it. If you don't remember what systems of equations look like, they look like this. Right? Systems of equations or simultaneous equations, you're given more than one equation and more than one variable, and the traditional way that you solve this is either by what's called elimination or by substitution. Basically, you solve for one of the variables in one equation and you plug it into the other equation. It's a lot of work. So with this method, we're just gonna skip all that. We're just gonna skip right to the answer. All right, are you ready for it? So here we go. I'm just gonna write the answer. X is equal to, here's how it works. 2 times 10 is 20 minus, there's a 1 in front of this y. 1 times 11 is 11 divided by 2 times 2 is 4, minus 1 times 1 is 1. That would be 20 minus 11 is 9, over 4 minus 1 is 3. 9 over 3 is 3. You just solved for x in like a few seconds. Wow. So at this point, to get y, you have an option. If it's easier, you can just plug 3 in for x into either of these equations and get y, but that's kind of just like the old method, so I'm just going to continue with my trick. So let's do the same thing for y. Y is equal to, and it works just slightly different than the last time. So y is equal to 11 times 2 is 22, minus 1 times 10 is 10, and then I divide by the exact same thing I got last time. I work in here, 2 times 2 is 4, minus 1 times 1 is 3. You can just keep the denominator here. It's going to be the same. So when you're solving for y, it's even one less step. So I'll just keep that as 3. 22 minus 10 is 12 over 3. 12 over 3 is 4. And there you go. You solved the system of equation without doing any elimination, without doing any substitution. Just wrote down the answer. Saves you so much time. So at this point, you might be wondering, why have you never heard of this? Where does this come from? This is actually something called Cramer's rule. It's something you learn in a linear algebra class or a matrices class. The reason you haven't heard of it is because it involves what are called determinants, and that's something that's defined for matrices. And I just kind of threw that all out. I didn't worry about doing any of the theory behind it, and I took away some of the intermediate steps just to get to the bare bone, just to get the answer as quick as possible. So if you want to look into the theory of Cramer's rule, you're welcome to, but this is the application of Cramer's rule. I just kind of removed a few intermediate steps for you. Let's take a look at one more example to make sure you've got this down. Here I have another system of equations, simultaneous equations. 3x minus y equals 2, 4x plus 5y equals 1, and let's do the trick. So here we go. X is equal to, and remember how this works, we do minus 1, so we do the coefficient of y here. Minus 1 times 1 is minus 1, minus 2 times 5 is 10, divided by, and this time we go the diagonals the other way. Minus 1 times minus 4 is 4, minus 3 times 5 is 15. If you simplify this, minus 1 minus 10 is minus 11. 4 minus 15 is minus 11. Something over itself is positive 1. How do you do it with y? Remember, this time we take the coefficients of the x. I do 2 times minus 4 is minus 8. Minus 1 times 3 is 3. All over. And remember, the bottom, the denominator, it's just the same from the last time. So you can just keep this, keep the denominator the same. Don't even worry about computing that the second time. Minus 8 minus 3 again is minus 11 over minus 11. That's again 1. So x is 1 and y is 1 in this equation. And if you're ever not sure, if you ever feel like you made a mistake, you could always plug these numbers back into the equations and make sure they make sense. If I plug 1 in for x and y, 3 minus 1 is 2, and minus 4 plus 5 is 1. It works out. Before you try this trick on your problems, make sure you have the ordering right. Make sure you know which numbers to multiply and when. When you're solving for x, it's this times this minus this times this. And when you're solving for y, it's this times this minus this times this. Make sure you have the ordering down for the numerators. Now I know what you're thinking. You're saying, Brian, this is great. 2 by 2 systems of 2 equations and 2 unknowns, 2 variables. That's great. You just saved me a lot of time. Thank you very much. What if I have more? What if I have 3 equations and 3 unknowns? What if you have more than that? So here are 3 equations with 3 variables. Can I use my trick for this? The answer is yes, but it's probably not worth it. Cramer's rule, this trick, it gets a little bit more complicated the more equations you use. You can learn the details if you take a matrices or linear algebra class, but I actually wouldn't recommend this trick for more than just 2 equations. It kind of just gets a little bit too complicated and a little bit too much to memorize as a trick. If you do want to learn the best way to solve this system, and actually exactly this system, you can click right here and you can watch my video on what's called Gaussian elimination. That shows you how to solve a system of 3 equations and 3 unknowns the best and most efficient way. In this video, you learned one of the most powerful and time-saving algebra tricks out there to solve systems of equations. I really hope you got something out of this video. If you found it helpful, I would really appreciate it if you would subscribe to my channel and tell your friends to watch this video too so they can learn the benefits of this trick. Thanks very much for watching. Have a great day.